It's a quiet night, you open your phone, type an address, and a blue line instantly appears on the screen telling you to turn left in 200 meters. You follow it without thinking. Yet behind that simple blue line lies one of the most sophisticated technological systems ever created. Most people rarely consider how their phone knows exactly where they are, which road is fastest, or what traffic conditions look like miles ahead. The answer involves satellites in space, massive geographic databases, billions of smartphones acting as sensors, and powerful algorithms working together in real time. This hidden infrastructure is what powers Google Maps. Every day, billions of people rely on digital maps to move through the world. Taxi drivers navigate unfamiliar neighborhoods, delivery riders search for the quickest route, tourists explore new cities, and emergency responders rush to hospitals using directions provided by the same invisible system. Even industries far beyond everyday navigation, airlines, shipping companies, logistics networks, and urban planners depend on these digital maps, but maps were not always dynamic and interactive like they are today. For most of human history, maps were static objects printed on paper. They represented what the world looked like at a specific moment in time. If a road changed, a bridge closed, or a new building appeared, the map would not reflect it until a new version was printed. In a rapidly changing modern world, this limitation became a serious problem. Traffic can appear suddenly, construction zones emerge overnight, and accidents can block major highways within minutes. The challenge was no longer just mapping the planet, it was mapping a world that constantly changes. Navigation before digital maps could be frustrating. In the 1990s, driving through an unfamiliar city often meant unfolding a large paper map or following vague directions like turn left after the gas station. Missing one turn could lead to confusion and wasted time. Businesses lost efficiency. Delivery drivers burned fuel searching for the right streets, and emergency vehicles sometimes struggled to find the fastest routes. A major breakthrough came with the development of Global Positioning System, commonly known as GPS. Originally developed by the United States Department of Defense, GPS consists of dozens of satellites orbiting Earth at an altitude of about 20,000 kilometers. Each satellite continuously broadcasts a signal containing its precise location and the exact time. A smartphone or navigation device receives signals from multiple satellites at once. By calculating how long each signal takes to reach the device, the phone can determine its exact position on Earth through a method called trilateration. Within seconds, your phone can calculate latitude, longitude, and even altitude with remarkable accuracy. But GPS only answers one question: where you are. It does not tell you what surrounds you. To guide people effectively, a navigation system needs an enormous database of geographic information: roads, intersections, bridges, highways, buildings, and landmarks. When Google entered the digital mapping field in the early 2000s, the challenge was staggering. Create a detailed map of the entire planet and keep it constantly updated. To achieve this, Google built one of the largest geographic databases ever assembled. It contains millions of kilometers of roads and billions of buildings, along with details such as street names, turn restrictions, traffic signals, and speed limits. Yet the most revolutionary aspect of modern digital maps is that they incorporate time as a variable. Instead of showing only static roads, they understand how traffic flows through those roads. This real-time awareness comes largely from smartphones themselves. Whenever someone uses Google Maps with location services enabled, their device anonymously shares movement data with the system. Each phone effectively becomes a small traffic sensor. If hundreds of devices on a highway suddenly slow down, the system detects congestion almost instantly. When traffic begins moving again, the map updates accordingly. Through millions of these signals, the platform learns how traffic behaves at different times of day and under different conditions. The result is a living map that reflects the movement of people and vehicles across the planet. Another major source of data comes from the imagery collected for Google Street View. To capture these detailed images, Google deploys specially designed vehicles known as Street View cars. On top of each vehicle is a camera system with multiple lenses that capture panoramic images in every direction. As the cars drive through streets, they photograph buildings, intersections, road signs, and landmarks. These images allow users to virtually explore neighborhoods and cities from their devices. Street view vehicles also carry advanced sensors such as LiDAR. LiDAR systems emit thousands of laser pulses every second. When these pulses reflect off nearby objects and return to the sensor, the system calculates precise distances. This process produces highly detailed three-dimensional representations of roads, buildings, and surrounding environments. To reach places cars cannot access, Google has also used backpacks, bicycles, snowmobiles, and even camels equipped with camera systems to collect imagery from remote deserts, mountain trails, and historical sites. All of this information, satellite imagery, street-level photography, sensor data, and user movement patterns, flows into enormous data centers filled with powerful servers. There, machine learning algorithms analyze vast amounts of geographic data. These systems automatically detect roads, identify buildings, recognize traffic signs, and update map features. If satellite imagery reveals a new road or traffic patterns suddenly change in a specific area, the algorithms may update the map accordingly. Every time a user requests directions, the system must solve a complex problem, determining the fastest route among countless possible paths. To do this, advanced routing algorithms evaluate road networks the way a chess engine evaluates possible moves. They consider factors such as distance, current traffic conditions, historical travel times, road restrictions, and time of day. Sometimes the fastest route is not the shortest one, and the system can determine this in just milliseconds. Beyond helping individuals navigate, digital mapping technology influences entire industries. Urban planners analyze traffic patterns to redesign city infrastructure. Ride-sharing companies rely on mapping services to match drivers with passengers efficiently. Logistics companies optimize delivery routes using these systems, reducing fuel consumption and improving efficiency. Looking ahead, mapping technology continues to evolve. Researchers are exploring artificial intelligence systems that can understand environments more deeply, recognizing storefronts, entrances, parking areas, and pedestrian pathways automatically. Augmented reality navigation could overlay arrows and directions directly onto the real world through smartphones or smart glasses. Autonomous vehicles will rely on extremely precise digital maps accurate down to centimeters, requiring detailed information about lanes, curbs, and road geometry. At the same time, such powerful mapping capabilities raise important questions about privacy and data usage. Billions of devices contributing location information create an incredibly powerful data system. Balancing innovation with transparency and user trust will remain a key challenge as mapping technologies continue to develop. Still, the scale of the system is astonishing. Satellites orbiting Earth transmit positioning signals. Specialized vehicles capture images and sensor data from streets around the world. Data centers process enormous volumes of geographic information. Billions of smartphones quietly report movement patterns. All of these components work together to maintain a real-time digital model of the planet. The next time you follow the blue line on your screen, it's worth remembering what makes it possible. Behind that simple route is a network connecting satellites in space, vehicles mapping cities, servers analyzing massive data sets, and billions of people moving through the world. Together, they are building something extraordinary. A living map of Earth that is never finished, never static, and always learning.